Hi, welcome to the video solution for Edexcel IAL Physics. This is Edexcel IAL Unit 4 WPH14. This is October 2020 paper. So let's start. Question number 1. Two equal positive charges are placed at Y and Z. Point X is equidistant from Y and Z. Which of the following shows direction of the electric field at point X? So we have two charges Y and Z, and X is just a point or a position, and Y and Z both are positive charge. So the electric field due to Y at X will be in this direction. This is the electric field EY. And electric field of Z at point X will be in this direction if you keep drawing EZ. So we have two electric field acting at point X, and electric field is a vector quantity, and we need to find the resultant of these two electric field. Clearly you can see that if you add EY and EZ, the electric field will be, the resultant electric field will be in between these two, because they have equal amount of charges. So EY, in terms of magnitude of EY is equal to magnitude of EZ. Magnitudes are same, so resultant vector will be exactly in between, vertically down. So option is B. Question number 2. A student writes the following equation for the decay of a neutron. Which of the following conservation laws is violated by the equation he has written? So one thing that you can directly or immediately, you can see that, remember, after decay process, this is just an idea, after decay, if you have electron, you must have anti-electron with this. Or after decay, if you have positron, then you must have electron neutrino. So along with electron, after decay, along with electron, negative electron, there has to be anti-electron neutrino. Or if positron is emitted, then along with positron you must have electron neutrino. So clearly if you have this concept, you can save your time. You can directly check D is the option. Lepton number is not conserved, but for your understanding, I am checking one by one. Let's check baryon number. So baryon number of neutron is +1 arrow, baryon number of proton +1, and then baryon number of electron and electron neutrino is 0, are 0 0, so 0 0, and you can say that +1 before and +1 after, so baryon number is conserved. Similarly charge, so before decay, neutron has 0 charge, proton has +1, electron has a -1, and electron neutrino no charge, 0. So +1 -1 cancel, so 0 and 0. So charge is conserved. Similarly energy, we cannot check the value of energy, but it is assumed that if generally energy is always conserved, including rest mass energy and the kinetic energy. So the rest mass energy of the neutron is equal to the rest mass energy of these particles plus kinetic energy, because these particles must be moving. So we assume that energy is conserved. Let's check lepton number. So this is a neutron. Lepton number of neutron is 0. Arrow. Lepton number of proton is 0. Lepton number of electron is +1, and lepton number of electron neutrino also +1. So of course you can say 0 and +2. So lepton number is not conserved. Option is D. Question number 3. A potential difference V is connected across a capacitor of capacitance C. The charge is stored on the capacitor is Q. So the charge is stored in the capacitor is Q, and this Q would be equal to CV. This is the charge stored in that. Now the capacitor is replaced with two other capacitor of capacitance 2C each in parallel. This is the second diagram. What is the total charge now? Is it Q by 4 or Q or 2Q? Meaning you need to give answer in terms of the initial charge. You know that capacitors are in parallel. So the total capacitance is sum of the individual capacitance. So total capacitance or net capacitance will be 4C. So of course, the new charge, let's talk about Q dash, is the new charge stored is equal to capacitance, which is 4C, and the voltage. Both capacitors are parallel with the power supply, so voltage will be same. V, of course, CV is the Q. So 4Q. So Q dash is basically the new charge stored will be 4 times of the original charge. So option is D. Question number 4. The SI unit of capacitance is farad. Which of the following gives the base unit of the farad? So if you need to find base unit, you need to know or you must remember the formula of the quantity or the unit related equation. You know that we are talking about farad, and farad is the unit of capacitance, and formula for capacitance is C is equal to charge divided by voltage. So the unit of charge is coulomb per unit of voltage. Remember the basic definition of voltage. Voltage is defined as energy per unit charge. So joule per coulomb or JC inverse, joule coulomb inverse, is the unit of voltage, which is in fact volt if you recall your unit 2. So JC inverse is V, volt. So the unit of V is JC inverse. So you can rewrite these as J inverse and C square. But we need to give answer base unit, remember. So immediately you don't waste your time for A and B because both are not a base unit. Base unit we need to give answer in terms of those 7 units: kg, meter, ampere, second, mole, these kinds of stuff, Kelvin. So you know that joule is the unit of energy or work, and in terms of base unit, J is kilogram meter square S minus 2. This is J in terms of base unit, and coulomb is ampere second. So now you can replace J with its base value. So J minus 1, and we have a J equal to this. So J minus 1 would be equal to kg minus 1 and M minus 2. Look at that, because if you put minus here, then all these power will change the sign. So J equal to this, J minus 1. So kg minus 1, M minus 2, and S square. And then coulomb square. This coulomb square, if you replace ampere second, so will be ampere square and second square. Finally, second square, second 4. So kg minus 1, meter minus 2, ampere square, second 4. Okay, ampere square, second 4. Option is C. Question 5. A gas molecule of mass m traveling at a speed v strikes the side of a gas cylinder at an angle theta. The collision takes time t. What is the average force acting on the side of the gas? Remember, mass and velocity given, time given, you need to find force. So force is nothing but change in momentum, rate of change in momentum. So m mv minus mu divided by t. So mv minus mu, final momentum minus initial momentum divided by time, gives you force. You need to apply this approach and find the change in momentum, because we have a given angle. That means momentum is not linear. We have two-dimensional momentum. So if you see, this velocity or momentum can be resolved into component. This is the tail and this is the head of the initial vector. So you can resolve the momentum into its component. So this is the one component towards the wall, and this is the parallel to the wall. Because parallel component is not going to apply any force applied by this vertical component. And according to this right angle triangle, this one will be opposite component, meaning you should use sign. This is opposite to the angle. So in terms of momentum, not velocity, in terms of momentum, this momentum component will be mv sine theta. So this is the perpendicular component, perpendicular to the wall, perpendicular component of the momentum. Now after collision, this is the direction of new momentum, final momentum. So you can figure out this is the perpendicular component. Of course, you also have a parallel component, but parallel component is not going to apply any force applied by this. So this is the change in momentum, new component. Clearly opposite, this says you can take minus mv sine theta, because this is opposite, because in terms of vector, if it is mv sine theta, it should be minus mv sine theta in terms of vector. So if you need to find F is equal to final momentum, which is minus mv sine theta minus initial momentum mv sine theta divided by time taken. Time taken is t, and then minus you can add. So minus 2 mv sine of theta divided by t. This is the force acting. This is a vector because we are considering direction. But if you see none of the option given in negative, we also reading question, we need to find just magnitude of the force. So for magnitude of the force, this negative sign can be ignored if you are finding the only magnitude. So of course this is 2 mv, so F is equal to 2 mv sine theta divided by t. This is magnitude of the force. Option is D. Question 6. An oil drop with charge Q and mass m remains stationary between two metal plates. With the potential difference V across them, the plates are separated by distance d, 0 and v, d. What is the charge on the oil drop? Clearly, you know that if the oil drop is stationary, the oil drop experiencing two forces is stationary. One is the weight, W, acting down, and electrostatic force, F, acting upward, so that it can be held at rest. So at rest, force F, electrostatic force, is equal to the weight, or mg. F, electrostatic force, is EQ, is equal to mg, because we need to find amount of charge or expression for charge. So and E between the two plates is potential gradient, V by D. So you can say E is V upon D into Q is equal to mg. Clearly Q is equal to mg D upon V. C. Question number 7. A proton enters a magnetic field at an angle as shown. Which of the following gives the direction of force on the proton as it enters the magnetic field? So we have options. So the easiest way is you are giving direction of magnetic field, right side, and proton is moving upward. So this is direction of motion, velocity, or speed or motion. So adjust your Fleming left hand rule. You have a proton, positive charge. If you adjust, so your the first finger of your left hand should be right side, and then the second finger should be upward, pointing upward. So this is your first finger of your left hand, and second finger you are pointing upward. Second finger. Then automatically you will find that your thumb will be pointing into the screen or into the page if you are working on the piece of paper. So this thumb will be into the page or into the screen. So of course into the page. Option is C. It is possible, remember, they might give you, instead of proton, if they give you electron. An electron is moving in the same direction, same magnetic field. So you will apply Fleming left hand rule in the same direction, exactly same. There is no difference at all. So you will be looking at thumb into the page. But because of the negative charge, so force will be acting in opposite direction of your thumb. If your thumb is into the page, then you will say that the force will be acting out of the page. Then option will be D. But in this case, because proton is a positive charge, so we take the direction of force as the direction of the thumb into the page. Question number 8. When a point object with charge Q is placed at a distance D away from another point charge 2Q, so we have a one charge plus Q and plus 2Q, distance is D, the force is F. Now the charges are increased from plus 2Q and plus 4Q, and the distance is also doubled. Which of the following gives the new force, which is quarter of the previous value, half of the previous value, as same as previous, or double of the previous? You know that force F would be equal to K Q1 Q2 upon R square. So K is constant. Force, indirectly you can say force is proportional to product of the two charges and inversely proportional to the square of the distance. So you see, according to condition, previously one charge was plus Q, now it is coming plus 2Q, and the plus 2Q becomes plus 4Q. So both of the charges are double. So Q1 is double 2 times, and Q2 is also double from plus 2 to plus 4. This is also double. So overall the product of the force is 4 times, and the distance is also double. If distance is double, then force is proportional to 1 upon 2D, meaning 4 R square or 4D square, so 1 upon 4. So the force will be 1/4. Now because they have to be multiplied, both Q1, Q2 and upon R square, you need to multiply. So 4 times 1 upon 4, 4 cancel, is equal to 1. That means there is no change in force. So option is F, which is C. Question 9. A turntable playing a vinyl records rotates at 33 revolutions per minute RPM. What is the angular velocity in radian per second? Easy, straightforward question. RPM. You need to times 2 pi divided by minute divided by 60. So whatever the value is given, this 33 should be multiplied by 2 pi, because 1 revolution contains 2 pi radian, divided by 1 minute contains 60 seconds. So divided by 60. This is in radian second inverse or radian per second. So of course it is 33 times 2 pi divided by 60. Option is C. Question 10. A magnet is dropped vertically through a coil, producing a current in the coil which creates a magnetic field around it. So this is the coil. Magnet is dropped. We have end X and Y. Which line of the table correctly shows the pole? Okay. We need to tell that when the magnet is dropping, what is the nature of the pole at X and then Y. So clearly you know that this is all about electromagnetic induction. When magnet is falling, then the magnetic flux of the coil will be changing and induced EMF is induced, current is induced. But because we need to talk about the ends, it's all about the question of Lenz's law. And Lenz's law suggests that, or Lenz's law states that the induced current or induced EMF produced in a way that it can oppose the cause that is producing EMF. So you know that at X, when the magnet is falling downward, north pole of the magnet is coming closer to the end X. So according to Lenz's law, the end X should oppose, meaning repel this end, and in order to repel this X must becomes N, so that same pole can repel. But of course it cannot stop, but it will try to stop, so try to resist, because north pole is coming closer, so the X is going to repel, and in order to repel, the end X should be north. So X and cannot be south, so C and D are immediately gone, so both are correct. X must be north. But now watch carefully. When the magnet is falling and coming out from the other end, that means if you see, south pole will be there and north will be there. So south pole will be going away from end Y. And Lenz's law says that the EMF opposes the cause. So this end Y is trying to stop the south pole, or try to stop south going away, and Y end needs to attract, so needs to attract, and in order to attract, the end Y also again becomes north, so that north and south can attract. So remember, when the north pole is coming, X has to repel, and in order to repel, X has to be north, so it can repel. But here Y has to attract, so north Y has to be north. So of course it is Y cannot be south. It is option is A. Question number 11. The photograph shows a model electric motor, a coil of wire mounted between two magnets. When there is a current in the coil, it rotates. The diagram shows the position of the coil viewed from one end. We are looking at the coil from either this side or this side, something like that, view one end. So at an angle, making angle of 20 degree with the horizontal, this is the view from one side. The current in the coil into the page at X and out of the page at Y. So current is going into. So if this is X and this is Y, that means current is going into and then coming out. That's the direction. And we are looking, if you are observing from there, and it is making some angle 20 degree, if you look at that. So there are 10 turns, okay, and 10 turns in the coil, and the current is 6.9 ampere. Determine the resultant moment about P, okay, of the magnetic force acting, and we are giving some data. First of all, you need to understand why are we talking about the moment here. Basically, this is the when the motor rotates, so we have a moment due to couple. Moment due to couple of forces, and couple are two forces, two equal magnitude, equal forces in terms of magnitude, two equal, I'm sorry about my writing, I'm just trying to improve, I'm really sorry, two equal forces acting in opposite direction. So those forces are called couple. So you can imagine you have a rod, any rod, maybe a plank or a steel rod, and one force acting in this point downward, F. Another same force but acting upward. So these two forces are equal in magnitude. So we have two forces, and these forces are coupled. Now what happened due to these two forces? These two forces rotates the rod according to the direction of the force. We know that the rod is going to rotate in this direction, and that is called moment. But this rod, there's no pivot, but according to these two forces, the rod is going to rotate about the center position. And in this case, if you need to find a moment of these couple, so moment in this case, if you are giving two forces, the moment is magnitude of the one force, any, because both magnitudes are same. So we take one force, any one, F, times distance between these two forces, D. Not from the pivot, there is no pivot. In case of couple, we take distance between the two forces or two ends, so D. F into D, this is how we can find the moment. So the idea is, here if you see the current is going into the X, as I mentioned here. So if it is not mandatory to draw the force arrow, but to visualize what is happening, why do we have a couple of forces? So current is going into the page, and this is the north to south. If you arrange your left hand, so your first finger at X, I'm talking about at X. So first finger is right side, and second finger into the page or into the computer screen. Then clearly your thumb will be downward. Thumb. So the force will be acting downward, F. Clearly Y current is coming out, so force will be acting upward. Now you can see that you have a couple of forces and magnitude will be same. So we need to find first force, and then we need to find the distance between the forces. So let me just erase. So we are going to find the forces, and we have a wire. So force is acting F. Consider only one wire because we need one force. F is equal to BIL. So this is your magnetic field. This is your length, and this is your current. So BIL 0.07, current is 6.9, length is 5 centimeter, 0.05. So yeah, 5 divided by 100. But if you do that, you have a current acting only one wire, and I have, or they are saying that there are 10 turns, so we have a 10 turns. So force acting on each wire, so total force will be times 10. And if you do that, F is equal to 0.24 Newton. So finally moment, MO, moment will be magnitude of the force 0.24 times distance between the two forces. So we need that distance. If this is 20, this is also 20, and this is the adjacent in this triangle, and this is the width 3.5. This is the width. So this distance D would be equal to cos component of 3.5. So but it is in centimeter. I will take in meter. So this d will be 0.035 cos of 20. So 0.035 cos of 20. You solve this, so moment would be equal to 7.9 into 10 to the power minus 3 Newton meter. This is the moment. Question number 12. Positron emission tomography, PET, is a medical imaging technique used to create three-dimensional images of the body. In PET, a low-energy positron collide with an electron. Positron colliding with electron to produce a pair of gamma radiation. So particle and antiparticle are colliding. Remember the term. Particle and antiparticles are colliding and producing gamma rays or photon or energy. Traveling in opposite direction, the gamma photons are detected and used from the images. Now name the process involved. So when particle and antiparticle colliding, creating energy, photon, gamma rays, this is called annihilation. Calculate the maximum wavelength of gamma photon produced. So basically, you need to find rest mass energy of the process. We have one positron coming, we have another electron coming, so we are going to figure out the energy. So rest mass energy or energy, because they are low energy photons. So we have you can start with E is equal to delta m c square, and we have two particles coming, so we have a double of the mass, 2 times of 9.11 into 10 to the power minus 31 kilogram. This is the mass of positron or mass of electron. We have two same opposite particles. That's why I'm taking 2. C square, 3 into 10 to the power 8 whole square. So delta E or E would be equal to 1.64 10 to the power minus 13. Joule. And now we need to find the wavelength. So we know that E energy is equal to HF, or energy is equal to H C upon lambda. But remember, the energy that we found is for positron and electron, and when they annihilate, we have 2 photons created moving in opposite direction, 2 gamma photon. So half of the energy goes into one gamma and rest of the half goes to the other gamma. So we need to find the wavelength of one gamma photon. So we need to use energy half of that value. So in fact, this E must be E by 2 is equal to HC upon lambda. So lambda would be equal to 2H. It should be H. Sorry. It is 2HC upon E. Now lambda is equal to 2 times of Planck's constant, 6.63 10 to the power minus 34 into C, 3 into 10 to the power 8 divided by E, and E is 1.64 10 to the power minus 13. So lambda or the wavelength will be 2.42 into 10 to the power minus 12 meter. That's how you can find the wavelength. Question number 13. In 1964, George Zweig proposed a model for matter, and Zweig suggested that mesons and baryons are made from a set of fundamental particles, what he called as aces. In this model, each ace carried baryon number of 1/3 and was fractionally charged. Baryon was combination of 3 aces, so mesons were combination of 2 aces. Zweig said that the number of aces should match the number of leptons, so there would be 4 types of aces. Compare this model with the current standard model. So basically you need to see what he did or what he said and now what we know as per standard model. So if you see that in Zweig model he considered aces as a fundamental particle. In standard, quarks are fundamental. So basically aces and quark, you need to compare these two behaviors. So aces are fundamental in Zweig model, and in standard model quarks. So aces and quarks both are fundamental in their own model. And as per Zweig, he was saying that baryons were combination of 3 aces, while in standard baryons are combination of 3 quarks, and mesons were combination of 2 aces. Mesons are made from 2 quarks. So these are some similarity between these two. And of course Zweig said that each ace has a baryon number 1/3. Similarly, in quarks, we have each quark as a baryon number of each quark is 1/3. So these are some similarity between these two models. But when Zweig is defining the combination of or formation of mesons, he just said that combination of aces, there is no differentiation whether we have different types of aces or what. But in quark, we know that mesons are made from a pair of quark and an anti-quark. So this is the difference between these two. Moreover, he said that there have to be 4 types of aces, but in a standard model, instead of 4 quark, we have 6 quark. So you can combine all these information in one statement or the bullet point. It's your wish. That's how you can write. Question number 14. In the alpha particle scattering experiment, a beam of alpha particles is directed at a thin metal foil. In 1911, Rutherford concluded that the atom has a central charge contained in a very small volume. Explain how the result of experiment led to this conclusion. So we have a small region contain charge. So the reason is when alpha particles was bombarded, it was observed that very few particles deviated from their original path, and this suggests that there has to be a small region with the concentrated or small volume with charge. So the few particles deviate or scattered. That's why we can say that the small region has a charge. Rutherford wrote the main deduction from the theory are independent of whether the central charge is positive or negative. Okay. Discuss why the observation did not allow Rutherford to conclude whether the central charge is positive or negative. Whatever observation is, from the observation we cannot conclude whether the nucleus is a positive or negative charge. If you recall, generally during your lecture, teacher used to say that we have a positive nucleus and alpha particles are coming. This is the nucleus, alpha particles are coming. So if alpha particle is coming from that side, alpha has a positive charge, so we have a repulsion, so it will deviate. And if some particles directly coming head on, so it will bounce back. This is the most typical model. But it is possible that, because see, we are not observing inside, we are observing these particles coming. This is our observation. We see these particles coming back. We don't see nucleus. So these two observations can also be explained if the nucleus has a negative charge. Meaning, suppose if the nucleus has a negative charge, and if one alpha particle is coming from this side, so it is possible due to attraction, this particle come this way. So we observe this. So the difference between these two observations is, this is force of repulsion between nucleus and alpha particle, and we have a deviation, and this is attraction between negative nucleus and a positive alpha particle. And also the second observation, most probably a high energy or high speed alpha particle goes back, and then due to attraction it is returning. So we can observe both the deviations, or both the observation, whether it is a positive or it is a negative. So both are valid. So that's why, saying that on the basis of observation, it is saying that the nucleus must be positive. It is a wrong conclusion. It might be a negative. But now we know that actually the nucleus is positively charged, but it can also be explained with the help of negative nucleus. So you need to explain all these behavior for positive charges and the negative charges, and it is better. They are saying that you can draw the diagram if you wish. So you can draw these two diagrams, call this diagram number 1 and then diagram number 2. And you can explain whatever I did in this way. So, and you can, of course, there is a room for, rearrange or rephrase the statement. It's up to you. Part C, we now know that nucleus is positively charged. An alpha particle with kinetic energy approaches a platinum nucleus and is repelled. The proton number of platinum is 78. Calculate the minimum distance of the alpha particle from the platinum nucleus. Assume that alpha particle and nucleus are point charges. So this is the platinum nucleus, and this is the alpha particle coming head on, and now this is the minimum distance and bouncing back. We need to find this R. Remember, when alpha particle is coming closer and closer and closer, potential V alpha or potential of alpha is increased as it coming closer. So potential is V is equal to K Q by R. But remember, in this formula, V is the potential of alpha, but Q is the charge of the main nucleus. Charge of main charge, or which is creating field, main nucleus. And this R can be found. But the problem is we do not have voltage or potential. That's why they give us energy. Because we know that V is basically energy per unit charge. But in this equation, this Q is the charge which is, moving. This is alpha, charge on alpha particle. So we use this equation to find V, and V can be used to find R. So let's find V. So V is equal to energy, which is 6.29. Let me erase this. 6.29 million electron volt or mega electron volt. So energy is 6.29 mega 10 to the power 6. Electron volt need to be converted into joule. So you multiply by 1.6 into 10 to the power minus 19 divided by the charge. And the charge is alpha. This Q is alpha. So charge on alpha, there are plus 2 charges equal to 2 electrons. So twice into 1.6 10 to the power minus 19. So if you solve this, or you can just cancel 1.6 and make, do simplification. So voltage would be equal to 3.15 into 10 to the power 6 volt. And now V is equal to KQ by R. You can give the reference, or you can directly write R is equal to KQ by V. And K is Coulomb's constant given in your formula sheet, 9 into 10 to the power 9 or 8.89 or something like that. Q, this Q is the main charge producing field, or the main charge. In this case, charge of the platinum nucleus. So the total particles are 78. So total protons are 78. So total charge will be 78 times 1.6 into 10 to the power minus 19. This is KQ divided by V. V we have found 3.15 into 10 to the power 6. You simplify this, then R would be equal to 3.56 10 to the power minus 14 meter. This is the minimum distance between the alpha particle and the nucleus. Thank you very much. I hope you understand this. If you have any problem, let me know in the comment sections. I will try to resolve your issue or your concept. So take care and have a nice time.